This is problem 4-81. Here what you want to do, you have two different materials. Let's see here, you have a large 50 millimeter diameter cylinder is made of magnesium here. I'll make that down to magnesium. And then here, this material, let's see what that is. That's stainless steel over here. So what you want to do on a problem like this is check to see what the coefficient of linear expansion is going to be. For the magnesium, your value of the magnesium, let's see what that was. That was 26 times 10 to the minus 6. And then for the stainless steel, we get 17 times 10 to the minus 6. Okay, so if you think about it, what's going to take place here, and I'm going to try to explain this hopefully pretty well, is since the magnesium here has a larger thermal expansion, it's going to expand, it's going to try to expand up more. We'll call this the expansion due to temperature. It's trying to do that anyway. However, the bolts, they're going to expand also, but not as much because the value here is going to be lower. So let me draw another rectangle and try to explain it. I'll do it down here. We can do it like here. Oops, let me do it because I want to make it shorter. Start out like what it originally looks like. But they're only going to expand up just a little bit because the temperature, because their expansion ratio is smaller. So when that happens, as a result of this not being able to expand as much, it's going to create a force on these bolts, forcing it to go down here. So regarding the bolts are going to feel a force like this. Let's see if we can draw this right. Well, the bolts over here, while the big diameter cylinder here, since these values differ, this one's going to feel a force is to want to push it, to compress it, because the bolts can't expand the same rate. The bolts are going to feel a force going back up, like this. And if you think about it, it makes true, because this your cylinder, it's going to try to expand back up, which is going to push up on the bolts. It's trying to extend the bolts here, so it's going to increase it here. The bolts are going to try to push back and compress that. So this is what's going to take place. So basically, let's go down here. All you're going to do, again, is do your two equations. You have your thermal expansion of the material, coefficient, times the length, times the change in temperature, and you're going to do plus PL over AE for all these. So for the bolt, you're going to be adding the PL over AE. For the larger cylinder, you're going to be compressing it. So just write those down and we'll solve for F, and that's all you got to do in this problem. So we'll start with the magnesium first. Its coefficient, like we said, is going to be 26 times 10 to the minus 6. We go back up here. Its length is 100 millimeters, so that would be, what's that, 0.1. And your temperature, you went from 20 Celsius to 130, so it'd be 110. And now we do the minus the force coming down on it. So we do PL, which is 0.1, over AE. And the diameter here would be, we'll do pi d squared divided by 4. And we're getting the diameter from the text anyway. Okay, so that's PL, and then we got to include the E value, which in this case will be 44.7 times 10 to the 9th. Okay, and all we're going to do is set those equal to each other. And when we do the stainless steel, again, we're going to do F. Actually, we'll do the thermal expansion first. Do the thermal expansion. That's going to be 17 times 10 to the minus 6 times its length, which is 0.150, times the change in temperature. And that'll be that, and then come down here and we'll do the force. And again, it's going to try to lengthen it, so we're going to be adding the force in this case. So P times L will be 0.150 over these, and we have two of them, so you got to consider, you can't just do one, you got to consider two. So we do pi d squared divided by 4. And then times the E value here, which would be 193 10 to the 9th. And again, all you have to do is solve for F. F is your unknown because you have an F here and you have an F here. Again, be careful, the signs are critical, because if you change the signs, you're going to mess this problem all up. But if you think about it from a logical standpoint, it does make sense. And when you do, you'll get F as 904 newtons. And that's it. That's the completion of problem 4-81.